Okay, predicting products. Part 2 reactions, predicting products for the following reactions. I'm going to start over here. These are the 2 reactions that generate carbocations. When can carbocations rearrange? When they are one away from a branched carbon. So if you have a C with a plus charge that's one away from a branched carbon, rearrangements are possible and they will happen. Okay? So if I generate a cation here, it is a candidate for rearrangement right here, because the next carbon over is branched. If I generate a cation here, it is not a candidate for rearrangement. So only one product will come from that cation there, and it will be a minor product. So I'm going to draw the most minor product right now. Phenyl, methyl, methyl, C with a new OH right there. And another minor product is the unrearranged with the other cation. But I'd like to point out that this cation, which is not worth any points whatsoever, is a candidate for rearrangement. The red rearrangement, and don't ever do this on a mechanism question, and the orange rearrangement. You can't do 2 rearrangements at the same time, ever. But this is not a mechanism question. I'm going to draw the orange result right here. Methyls are still where they used to be. Phenyl moved up here. Where's the cation? I'm not going to draw the cation. I'm going to draw it temporarily. When you move the phenyl away from this carbon, the cation was here, and what goes where they're getting no points for that. 0 points for writing that down. You wasted your time. That's an intermediate. It says predict the products. Okay? So don't draw intermediates here ever. What goes where the cation was? The bottom products I drew, what goes there? OH. So get rid of the cation and put an OH where it belongs. That's the orange rearrangement makes that product. The red rearrangement will give the most superior product big time. I didn't even ask that. But I moved the phenyl up here. No. Red rearrangement. That's a methyl up there. Methyl, phenyl still here. Methyl's there now. Cation is here. Now, truly, this would be the major one. I know this is tertiary, this is tertiary, but guys, phenols have pi bonds in them that can resonate with cation. I'm not even testing that on this test. I got 2 major boxes. Pick the 2 tertiaries. So what goes there instead of the plus? Don't draw the plus, please. You get no points for it whatsoever. OH, done. The 2 major products have the tertiary carbocations that became alcohols. You don't get points for drawing carbocations here. No. And your 2 cations over here are both candidates for rearrangement. I will prove it. Cation number 1, candidate for rearrangement. Cation number 2, also candidate for rearrangement. How do I know? Next door is a branched carbon. Not this way, but here, next door is a branched carbon. The things you're allowed to move are the H, that'll be the red product. The green will be the green product. The orange will be the orange product. And the blue that I drew originally, I'm leaving unrearranged here. And this is not OH reaction. What's going to be at where the cation goes this time? Cl. Oh. So that's no rearrangement. Red product right here. Red product. H moved. H is now, was bridgehead, now is here. Cation is here. Don't draw the cation, not worth any points. What goes there? Cl. I don't need that H if you don't want to. Orange product. We didn't do green yet either, I know. Orange. Copy everything except that bond you broke. Do not copy that next bond. Okay, that goes here to a square. That's still there. That's still there. That's still there. Sorry, they're overlapping a little. But now this is bonded down here. And the cation is, I'm going to draw it temporarily. That's where you moved it away from, right? What's going to go there? Cl. That's not a great product. In fact, you could argue you shouldn't get points for that because you went from a secondary cation to another secondary. But I'm just testing to see if you know how these things work. I'll probably give it to you, even though there's no driving force for the mechanism. And the green product, I think, will be a similar story. Copy everything except for that bond where the green started. Okay, we didn't break that bond this time. And the new bond is down from here to here with a cation. I'm going to draw the cation, but you know it's not a cation for points. What goes there? What goes where that plus is? Cl. So that's all the possibilities for that left molecule. Of all the possibilities so far, I like the red one, don't you? Yeah, tertiary. But I don't think I'm going to be circling those in the end because every one of those molecules has a square in it. There's two rearrangements that we're going to do down here on the other one that get rid of the square and make a cyclopentane. Oh, yeah. Here's your rearrangements down here. You got the H. We got to make sure we use all the colors we can. Hot pink. We'll go with baby blue for this one. You see all the rearrangements start from a bond off of the adjacent carbon. And we're going to go with orange. We did orange. Light pink. Two pinks. Yellows don't show up very well. We didn't do purple. This bond can also rearrange. Let's do the purple one first. 6, 6, stayed, moved next door to there, and left a cation there. Don't put the cation, what goes there instead? Cl. I like it. I know it's secondary, but there's no cyclobutane, so forget about primary, secondary, or tertiary. It's not about that anymore. You got rid of angle strain and torsional strain. No, you get rid of. You reduced them. Sorry, you never get rid of them. So that's purple. Let's do black. Of course, we should have done blue. Blue is unrearranged. It's the easy one. Do the blue one first, please. And the CL is here. No rearrangement for blue. But the black one will be black. It's not black. Pink. The black atom moved. So skeleton looks the same. And the H moved over here. And you got a cation right there, but don't draw the cation. What do you put there instead? CL. So that was the H shift. Baby blue. Everything except for that bond we broke. So the 6 top left is still there. This is still there. This is still there. And this is still there. And it goes, oh, I don't have room now. Two and two. 1. Okay. Out to a square. And we're now bonded here to here with a cation. You ready for it? The cation is right there. What goes where that cation is? Don't draw the cation, no point. CL. Oh. I was just tidying up with dots. Sorry. I think it was there, right? That's the blue, and we got the pink, we got the baby blue, we got the purple, we got 4 products from each one. There's your answer. 4 products from each one, 2 of them unrearranged, and then all the possible rearrangements. Yeah, we want to circle both the ones that no longer have cyclobutyl. And I don't believe this question asked for an explanation, did they? Did it? It did? Oh, we went over time. Yeah, we're done. Thank you. Stop share.